So what we're doing is a lot of the other TPO plants have a care training facility. I don't know if you guys have ever participated in the care training where they bring in operators and teach you how to build the roof, from putting down the ISO board to putting down the TPO, doing the welding, doing the hand welding, that kind of thing. But unfortunately, your plant's kind of smaller and doesn't have that facility. So we kind of come up with this little training program we're going to take on the road to all the plants. You guys just happen to be the first one because you're right in my backyard. And like I said, you guys don't have the luxury of having a care training facility there. So day one, we're going to go through the hands-on demonstration on actually how we weld the product, how it's welded on the roof. Which hopefully will kind of reinforce to you guys some of the things we gripe about and why we gripe about it. Pin lines, for instance, why they're there. Does everybody know why we got 2 pin lines?
One's for leads and fasteners, and not something like that.
Rear plug. That's
Yeah.
it. So the first set there is 3 inches in is for a fully adhered deck where they come out and they put the ISO board down and they take glue and spray it all down and they stick it, or like you peel and stick, you guys think. The second one is for the fasteners. So they're literally taking a big screw and driving a hole through it at the fastener mark. So they're putting a hole in it. That's not waterproof anymore. So you got to come to that second line, weld there, and then it becomes a watertight membrane. We won't do the hand welding. I understand you guys do some hand welding though for the SA. When you guys make the splices.
Yeah.
You guys are familiar with that. And like I said, just other than the pin line, some of the other stuff like the banana curl or the lay flat at the edges, if it's kind of wavy, what kind of problems that's going to have on the line. When we cut our samples this morning, we cut them kind of small, and it still has some curvature from getting at the roll. So it kind of simulated some, what those guys might see on the roof. But they're supposed to just roll it out, let it lay flat, kind of relax. We all know that's probably not the case, right? Another thing is, you guys recently went through the change. We had pin lines on one side, now we got them on the other side. The reason behind that is, one, we were the only one in the industry that was doing it the way we were doing it. And 2, now they can roll the roll out, and as they're rolling it out, they can run the robot right behind it. Right? But before, we had it on the other side. You had to roll the full roll out, get to the other end, and bring the robot back. So that's kind of the reason behind that. The other reason is, when you guys went through the battle card training, is that we try to give the contractors every advantage possible, with the lines, with the fastener locations, and all that stuff to ensure that they install our product correctly. So, I know you guys had a little hiccup with the fleece a month or so ago. It's still a good product. It's just the fact we covered up the pin lines, so they're going to have to go up their chalk lines now and snap those and get their straight edge. But, it's still a good product. It's just we had a little snafu there. What else? So then once we do the welding, we'll have you guys test your own welds like they would on a roof. So what they do is they weld just like we will with the robot. They cut a little section of that weld out and they pull it apart. Right? So they're looking for film tearing bond, looking for the material to give up and not the weld to give up, basically is what we're looking at. And just like when you weld with metal, that weld is the strongest bond. It's much stronger than the actual product itself. Then we'll go into the lab. I know you guys probably do color measurement, and you're going to do your thickness strips, right? But I don't know how many of you have run the Instron before, or kind of understand that aspect of it. We'll go through the melt flow of the polymers, why we do that kind of testing, and then some of the other stuff, low tin flex, encapsulated edge, color. You guys do color too, though, right? Measure your own color. Again, the younger fellow this morning had 10 different color, I think. Then we'll talk through some defects, pinholes, lines, different things like that. They also want me to talk through the RMA and the claims process. So for the commercial side of this business, for the last year, we have had 0 plantings. RMA is a return material authorization. So basically, customer gets product, they don't like it, they bought too much, something's wrong with it. We authorize them to send it back to that number, right? You guys have probably seen some RMA product come through. Most of the time, it's for, again, over ordering, not ordering the right stuff, the wrong stuff shipped, something like that went wrong. It hasn't been an actual product defect that has caused us to bring in material back, especially not to this point. But sometimes you guys might see them get the RMA material back and then go ahead and regrind it. Well, the reason is probably because it's dirty, and it's been through the mill. We don't want to try to sell that again as good product, so we're going to grind it up, pull it back in the floor, and make it all go away. I think of anything else. Do you guys got any questions before we get going? Has anybody ran the robot before? The welder? And then, if we get through everything on day one there, and then tomorrow, we'll go through some other stuff, kind of talking through the quality bonus, what we actually do down at the lab to generate those numbers, warehouse audits, SBC basics. Again, not getting too in depth with that, that side of it, just exposing everybody to it. But the bigger bulk of day 2 is going to be walking the actual line itself. You guys are all, seasoned veterans out there, so you guys will probably help us out. The TPO folks got together a few years ago and come up with a workmanship guide. So it'll show a picture of, say, streaks, right, going down through there, and then it'll say, all right, check your TI2 feeder, check this, check that. So it not only gives you what the defect is, it's also going to tell you the part of the line to go look at. Again, you guys probably know that back of your hand, but we still wanted to walk everybody through it. So I might learn some stuff from you guys that I don't. Yeah, that's pretty much it, folks. You guys got anything? All right. Let's go do some welding. Zach, you got that in? Pull that release. There you go. Shove it all the way over. Start running. Don't let off the board. Yeah, that's it. That is it. Everybody in the very end. Push that forward. That'll probably make it easier, Brady. Hey, man. The bend is still going to get you a little bit. Yeah. Other side. Yeah, definitely. Overlap. Lift up the back end. Pull back a little bit. Oh, yeah. Wheel line up.
just let it eat, Jeremy. Let it go all the way.
Yeah.
Well, you guys can see how quick it is for that stuff getting dirty. You got it. That seam out there clean. Right. Like that, we're gonna get it back up. Well, I'm talking about doing that. Yeah. Well, or it'll leave it, maybe it's out of bed. Certainly, I did in the past. Man, it just depends. If it's like a school or something, they want to take a picture of it. And then, everybody 30 feet. But most times, soap and water take it off. You got it underneath it?
I believe so.
No, we did all.
Started working, so we jumped on it.
This will be alright.
Still there.
Keep the water on it.
Slide all the way over. Go.
Well, we take off our adjustment.
Yeah. Once it's not to get over far enough to the edge, start off. They're gonna set it down. Set it down and slide it down. So everybody just grab one of your samples off there. Alright, so you grab your welds, both hands, right? Yank it apart. Alright, so what you're wanting to see is exactly that. So it's considered 100% film tearing bond, meaning that the TPO gave up, not the weld. Alright? Then, I got it inside. So, the spec says you're allowed 75% to 100% film tearing bond. Obviously, it's 100. And this is exactly what the guys will do on the roof. They'll make a little test. They'll probably use a pocket knife or something to cut theirs out, and they rip it apart. And then, like I said, as the day goes on, the temperature rises out there, and they're going to have to make adjustments to it because hotter is not always better. If you want it to melt, you get too much melt.
So you said they set that at 11:48, is that right? But as the day goes on, then they have to dial it back
Right.
because of the heat.
The heat that the sun's putting into the sheet.
Okay. So it's not necessarily a GAF standard. You have to have an 11:48 on the machine.
This is what we test at. That's why that's on there.
Okay.
So we all try to test exactly the same. Of course, we're in a somewhat controlled environment here rather than the sun hitting. All right, so this is one of them. You see the surrounding up this morning. It sat there for just a second. It oozed out a little bit. All right. That worked out better than I thought. We had some other morning. So that's what it looks like. So you see the difference there. The weld gave up, not the material. And like I said, it did take, but it could have gave you that. Yeah, that was a partial same thing. So it just sat there for a second. I mean, it wasn't long. I was standing where Tim was, I saw it smoking, and he got it clicked in and started moving. And it didn't, like I said, it just wasn't a second. Now normally what those guys will do is they'll want to raise the temperature. They can't get it to weld. Sometimes that works with white, but with the darker colors that does not work. Because that UV is getting into that sheet and it's changing that sheet chemistry, putting more heat into the sheet. Then when you try to weld it, it don't work. So again, you guys can see how important the lines are, lay flat, banana curl, the whole smear. Again, this is a small section. You can only imagine doing 100 foot of this at a time. Alright, so we'll go in the lab. We'll walk through the instruments and that kind of thing.
The Instron is basically going to do what we did, only much more controlled, much more repeatable, that kind of thing. Because just like Kleenex, it's just a name brand, right? That's the manufacturer of it. But Instron is one of the best ones. So technically, it's a universal tester. It can be set up to push or pull. Right? In this case, we're going to be pulling. This top one is actually a load cell, just like you would on a scale, so it tells you how much force is being, applied to pull it out. You can see the numbers changing up here as I pull on it. And so inside this housing, there's two big screws that rotate and move it up at a certain pace, right? So the test we're going to do today is called ply adhesion. So it's just exactly what you guys did out there, only we're going to use the machine to do it, all right? So what you normally do is come up and they'll grab the right test method. Tells you to set your limits, which you've already done that. So who's first? Want yours first? All right. All right, so the way you put your sample in. Like that. Like that. Yeah, okay, top and bottom. But you already knew the foot pedal thing.
Oh, yeah.
Yeah, I'm in flip over too, I didn't know that.
Alright. Start test, right?
Start test, yeah. Alright, so what you guys will see in these graphs is the first graph's going to be a steep up climb, right? And when it makes that first tear, you'll see it drop. And then as it keeps tearing, it'll keep making those little waves all the way down. And then down here, we'll record, the min, max, what the range was. So we'll see who's got the strongest weld out there. And you guys will probably be pretty close, pretty grouped together. You guys all did good with the welder, but you'll see the variation in the product.
We're gonna do all 4 samples.
No, each other.
It's just the one, okay.
Yeah. All right. So this sample, this takes a little bit of time to run. What he's doing over there is called a tear test, where you just cut that square, you put a little nick in the top. Oh, here's one for TPO. You put one on the top, one on the bottom, right, and it pulls it apart. This test takes about 10 minutes per sample, so it takes a little bit of time. The other test we'll do in the Instron is the tensile test. I'm sure you guys have heard of tensile strength before, right? It's the same thing, only it's just a blank little specimen. Same deal, top and bottom, hit go. The bigger thing with any of these samples really is to make sure that when you get it in the Instron that it's in the grip straight up and down, especially when you're doing a tensile test like this. If you were to get it kind of in there crooked, then it's not going to pull the yarns right. You guys know how the yarns run in this thing, so you're trying to test that integrity of it.
That's your low temp flags, Ken. That's your low temp flags.
Oh, sorry. I used it for tensile earlier this morning too. Everybody said go with it. So Tim's right. This is a low temp flex, and so that's another test that you'll actually freeze, and then we bend it over a mandrel looking for cracks. All right. All right, who's next?
But how can we get, it seems like everybody's doing it the right way, the same way that machine's gonna do it every time. Does it? Why is it such different numbers?
You get a little variation in the sheet. You guys know that.
Yeah.
It's not totally
Okay, yeah, I
parallel.
guess.
So you're doing different sections of the, if we were able to do exactly the same spot, your numbers would probably be a lot tighter,
Okay.
a lot more grouped together. But yeah, you're right, the robot, that's why when we get detail membrane in, we don't hand weld it down there. We test it with the robot welder, because that takes the human element out of it.
Okay.
But you guys can see just from that, you're right. We all use the same welder. Everything was clean. And you guys see the difference in the numbers there. And granted, now they're all passing. They're all good welds. But you can see how some of them are tighter, some of them aren't. And it has nothing to do with the human because the robot's doing it. But, and so we do these tests. We do them. Todd and the guys do them. The other plants do them. And then we build all this data so we know if we see something all of a sudden real low, we'll go back and check it again to make sure we got a good reading the first time. and we still have a low reading, then we know something's wrong. You guys have been doing this 24 years up here, so, formulations have been in place a long time, machines been in place. You guys clearly have enough experience to run the line out there, but, the only thing you can't control are your raw materials coming in, right? So, we've run into some instances, and it hasn't been in the TPO world, it's been in my bid, but, where they're running along and they're getting bad tensile numbers, right? There's not a lever out there you guys can pull to get me better tensile numbers. You can put more product on, you can take more product off, but it's more of that scrim, when in their case it's a mat, right? And so from our perspective, we know things happen. What we don't want is, if there's something like that you can't control, don't keep making product, right? If you guys got low tensile numbers and they're real, you guys would probably pull off that scrim, get another roll of scrim up there and go again and try it. But that's what we want, is not to keep making bad product, especially on something you can't control. And those kind of numbers, especially your tensils and stuff, that's very dictated by what scrim you guys are using.
Does the well differ between new roll versus a roll been after for 6 months or more?
Funny, it doesn't. So a couple years ago, there was a study done where they took product you guys had made 20 years ago, pulled it off a roof, sent it to us, and we welded it to new TPO. And it welded just fine, it tested just fine. It was crazy.
That's a true 60 mil in though.
Yeah. And, the funny thing was that, Barkle was probably in on making some of that product back in the day, and then he was the guy testing it 20 years later, and it was still passed. So it was kind of cool to see it come full circle. And for us, But no, it doesn't seem to degrade too much.
So this is on warehouse some of that stuff for a little while.
Yeah, at least 6 months. Like, we have a rule in place where we don't want to test anything older than 6 months, so that doesn't throw another variable in there. We want it within the first, month or two of production. But no, like I said, we've been back 20 years. And it was exposed to the weather. It's not like it was sitting in a warehouse for 20 years. It was on the roof.
Was it the GF1 formulation?
Yeah. Yeah.
I know we were in GEW for a while.
All right, so some of the other tests they do, they'll do dimensional stability, right? And what we'll do is we'll cut this square out, put it in the oven for so long, and then we put it in this jig, holding it flat, and we measure with a big mic, right? Seeing how much it expanded or contracted at that time. And the control you guys have over that is your profile. Is your sheet flat, or if you got low spots, if you got a low spot towards the edge, or something going on there. So you guys can affect that, but that's about it. You guys can't affect anything else inside of there. That scrim still has to do what it's supposed to do. The reason we do that test, and there's a tolerance on that, is because your product's on the roof, so it's going through those heat thaw cycles. It's expanding, contracting, and we know that if it stays within this window, then we got a good product that's going to last for a long time. Very rarely do we see anything that gets outside that dimensional stability window. You guys, same raw materials, we got good suppliers, you guys are clearly good operators, so we don't have much issue there. So a little color photospectrometer, you guys know how that operates? Inside, you know what happens in the little box? Alright, so you guys, if you went and, you guys operate this all the time, or for you ever been to Lowe's or Home Depot and seen the match paints?
Yeah.
Same principle. Okay. Same machine. What you do when you put your sample in there, it shoots a light against that, right? And then those rays bounce back, and then it's got a filter in there that reads what it's supposed to be versus a standard that we have loaded in there, right? And so this little poster or whatever kind of gives you the explanation of, like I said, the L is just how light or dark, right? That's pretty straightforward. But your A is your green red, and your B is your blue yellow, right? So in color, if I were to mix equal parts green, equal parts red, I'm gonna get a dirty gray in there, right? And so when those readings come out, those LAB readings, it tells you where your hue is for that. And so we use a delta of 1.5. So delta of 1.5 or less, we know we got a good product, right? The hue and I, they say,
can't pick up anything below about 0.5 LTE. If you're, at one point in my life, I was a color matcher for some ink companies. I can see it a little bit lower than 0.5. But anymore, I don't think I can see it like I used to. But I could see a little bit different. So then you got it right by your eye, and then you obviously always bounce it against the machine. So you got some kind of backup. I just, Kevin said it matched, I actually have a readout that says, hey, it matched. So. But that's kind of what happens inside the little box there. I'll make that mix in there. And so normally we're going to get a C of A from those producers, and we're going to say that that's good or bad. But periodically we just check them, to make sure. And I think you guys just bounced a rail car not too long ago for being out of melt flow range, right? And so what this tester does is you put so much of the product inside here. This thing is very hot. Not right now, obviously. And then you put this little plunger on top, right? And it holds it in that chamber for so long, and then it'll start to extrude out. And then you let it go for, the test used to be 5 minutes. You let it go for so long, and you cut that off, that strand off, and you weigh it, and then that's your melt flow index. That's how you get it. So like I said, it's not a test we do a lot, but it's something we kind of do periodically just to ensure, because if they were to send you a car in with a melt flow, I can't remember what your ranges are, 12 to 14 or something. They sent you in a 10 melt car, and you're gonna see it once it starts the process out there, and you guys are gonna be fighting that, all night long, all day long, trying to get that melt bank right, and it's not gonna be right because you guys aren't used to operating in that lower window. Like I said, most of the resin producers are pretty good about keeping it within tolerance. Like I said, guys did have to bounce one. I know you guys fought the tails or angel hairs. Was that last year we fought that? Lionel fought that.
Yeah, when I first started running the Ineos again, that first car or two, we had triple it. Typically, we don't. I think some of the other plants fight it a lot worse than we do.
I know some of them do. New Columbia runs a lot faster, to be honest.
Yeah, they got some a lot more travel.
They do. Yeah.
Full car.
Yeah, their hookup's not real close to the silo. Anybody been to Valdosta? Anybody go down here? They've got theirs pretty close to the silo. And they've got some other cooling functions in there that's trying to help mitigate some of that. But they still get them. I used to work for a compounder, and the biggest problem we had was when the truck drivers would come in with the bulk trucks, and they'd want to get home and eat, and so they'd jack that pressure up and try to shove it in too fast, and that shear would cause that, we call it tails, but angel hairs to come off of it, stringers, and clog the whole system.
Typically, we don't ever have to clean ours out. I mean, it's odd if we have to take those apart and clean them out.
You guys get mostly rail, or you get bulk trucks too?
We haven't got,
We haven't got a bulk truck
Yeah.
in years.
it's like it's an odd thing for us to get on.
If we see any of those tails like you're talking about, usually it's up in the feeders. That's where we see all of our strands at.
I was already made it through the angel hair trap, and it's
Yeah.
up there, because there's a bridge over or something.
Well, it just build up on the wheels themselves.
What other tests am I missing from this morning? Oh, so, like on your color, you guys know there's an LAB, right? You guys know what those stand for? Or your L is how light or dark it is, right? And that's the only thing you guys can control. You can either put more concentrate in or starve some back. You can make it lighter or darker. The A and the B have to do with the red, green, and blue, yellow index. And so it just tells them where that hue is actually at inside of there. They say that a human eye, a non-color trained human eye can only pick up about 0.5 delta E or less. They'll see a color change. Anything below 0.5, you'll see the same color. In the earlier part of my life, I was a color matcher for a couple of ink companies, so I used to be able to see color really well, but I don't see it as good anymore. As we get older, obviously our eyes change, and if you don't do it all the time, it definitely makes a difference. But like I said, that's the only thing you guys control is either light or dark. You're at the mercy of American, right? American coming in. I know some of the plants use Techno Apex too, but you guys are American for the products you guys make here.
the RV product goes. You guys know where Rig Grip, you know where that one goes. I know why you put the film out on there. What about fleece pack? So they market
better, right?
it actually does, but they market it as an impact. So it's supposed to have, better impact quality, but you guys know how thin that fleece is. But the bigger bang for your buck is when they put that glue down and it actually sticks to all that carpet or fleece. It gives you much better adhesion down. You guys don't make any detail membrane. And of course your SA product goes down just like the other SA product for that kind of thing. So you're hand welding when you do the SA, what do you guys weld?
Basically, the splices in the back. When we're,
Tail to tail.
yeah. The old row to the new row.
Of
The big jumbo rows, SA.
okay, that's how you make your splice
Yeah.
changes on those Freedom, the SA line.
Yeah.
Line 2.
Yes, line 2.
There you go. All right.
And then back in the day, we'd weld RV. When we'd be making the flashing, we'd actually weld RV together.
Oh really?
Yeah.
I think anymore, like on the RTA strip, we don't even weld them until the hand welder, we just use that big tail
Yeah.
tape.
Is that working? Is it holding?
Well, the problem is if you welded them a lot of times, or you got it up there, the overlap, the knives would kick out, and you lose somebody gotta go over there and cut all these windows out and everything else to get the knives started again. Well, that tape, you can just put on the backside, that's not held up.
Oh,
Instead of
okay.
overlapping them, you can put them flat together and then fire knives
Yeah.
out.
I used to work on some printing presses, and they were roll changes, the same deal, we'd have to tape them, cut the tail, and let them go through like that. And so we recommend that they don't install our product down to a certain temperature, right? Because you can see how the hand welder or the welders would act. A couple of years ago, we had an issue, I think it was PVC, but kind of the same thing. They were trying to install, I want to say -20. And the problem was, one, it wouldn't weld, obviously. Two, it was cracking, and it looked like they had dropped a hammer on it. And that stuff was so brittle that it just made the spider cracks in it, I don't think we approved that warranty claim situation there, just based on that. But, like I said, that welder, you can see how it does, and obviously we can jack the temperature up, you can slow it down, but you can't overcome a sheet that's frozen solid, and trying to weld it together. It's just not gonna hold. And the other thing they'll do on the roof is they'll actually take a little pick, they call it a probe, and they'll actually try to stick it in there, kind of like your dentist, does the same kind of principle, to see how strong and how much of integrity you got in that weld.